Let's talk about motion.
Booster pad, this is a tutorial about a booster pad.
Hello everybody, and welcome to the booster pad tutorial. In this video, you are going to learn how to put a booster pad on the ground. In fact, you could put it in a moving shot, and we're going to be able to control what this booster pad looks like procedurally. Point is, this is going to be a three-parter. In the first part, we're going to talk about how do you actually make the booster pad, and this is mostly going to be procedural, shader stuff. We're going to be able to control the color, the speed, even the shape. You can get weird-looking booster pad. It's all going to be in there. In the second part, we are going to take a shot that I filmed or you filmed and whatever, and we are going to motion track it. The idea is we want to take this booster pad, put it in a moving shot, and then in part 3, we're going to do that. We're going to take this motion track thing, we're going to take our booster pad, we are going to combine them. Why do I want to do this tutorial? I don't know. I like the idea of it, and I think it looks good. So if you are interested, keep watching, but I think we have a sponsor for this one, luckily. So first, sponsored segment, and then we are going to talk about all of that. So I come to you in this pleasant area to talk to you about something even more pleasant than where I am, and that is the sponsor of this video, Micro Center. And I'm not going to be doing the same thing that every other schmuck in the game's doing, where they're like, hey, go to Micro Center, here's all the great things about it. No. I'm going to tell you all the reasons to not go to Micro Center, and then you can make your own decision. So number one, if you do not like variety, you don't want to be able to go into a store or the online marketplace and be able to get computers, laptops, networking equipment, peripherals. If you hate variety, do not go to Micro Center because they have too much in stock for you. They have over 30,000 items as described. You don't want variety. You want to go into a store and have nothing that you want, so don't go to Micro Center. If you also hate deals, you hate like buying something and they're like, oh, we can get it to you for cheaper, either at the store, like physical location, or online, do not go to Micro Center because they have too many deals. You're gonna save too much money. It's gonna make you uncomfortable. And also, if you're going to the in-store, their associates are a bit too friendly. They kind of know a bit too much, so you go in there, they seem like they know the answer to everything. Like, well, why do they not? So if you don't want associates that will help you and answer all your questions, do not go to Micro Center. If the idea of a new line of business solutions from Dell and Supermicro that are for high-end stuff, you're doing like serious computing and stuff like this, if access to that sounds kind of, I don't want a computer that's good, do not go to Micro Center, and especially do not get the new Supermicro workstation / server builder. It's going to be too good. Yeah, I want computers and like solutions from 2007. So for that, do not go to Micro Center. And if all that didn't convince you to not go to Micro Center, like friendly associates, variety, all these things, here's the final nail in the coffin to get you to run away. If you're a new customer, they're offering new customers like you 240 gig SSDs for free. That's too much speed. That's too much space. By the way, link in the description if you want access to that deal with the free SSD. And this is for new customers. It's only valid at a in-store location. So you go to a Micro Center and you only get one coupon per customer. You're not going in there and getting 10 SSDs unless you know 9 other friends. Hopefully you understood the gist of that. Micro Center, thank you for sponsoring. And now booster pads or whatever the fuck, I don't know.
So before I begin, just 2 things I want to mention very quickly. One, very clearly, I'm in a tent, so if the audio or the video is a bit weird, excuse the fucking tent. Although I did a pretty good job of setting up the microphone, the laptop, and all this, so there shouldn't be any problems. But second of all, this is actually my second time recording this tutorial, because the first time I actually did it in the woods. I mean, I'm still in the woods, but I did it out in the open in the woods, and it was a great recording, but OBS or Windows, somebody is to blame, and I'm going to figure it out. I'm going to talk to their manager and ask why those files were lost. Either way, we're doing another recording. So either way, part 1, this is where we're going to make the actual booster pad, all the procedural stuff going on, etc. Let me show you a quick demo of what it is we are going to make. So you already saw the result, but again, this is just the raw design of it, right? Just this arrow booster paddy thing. It's not in any scene, not in any whatever. And you can see it's pretty much almost entirely made procedurally, except for this one image texture that we're going to be making. But when you look at this, you actually see quite a bit going on. So you're going to see that there's some arrows, of course. You're going to see a checkerboard, some dots, some colors. And long story short, we're going to need to make each of these components and combine them in a meaningful, or really an aesthetically pleasing way that they look good. So without further ado, I guess let's just do it. I'm going to be making sure that this is EV compatible because I don't want cycles. Screw that. So Before we get into the procedural stuff, as I mentioned, we just need to make one texture, and that's the image of this kind of arrow that's going up and down, because that's a little hard to do procedurally. So to do this, just add in a plane. In the top view, we're going to go to wireframe, so you can imagine this plane is kind of a bounding box, is the way I want you to treat this. Make another plane, so I duplicated it. And then I'm just going to model, using loop cuts and all this, a simple arrow. You can see it's like in the bounds of this frame. So basically, it's kind of done, right? So you basically just want to render this in Eevee, make the background black, take the object, make it white by creating a material, shading. Don't want the BSDF, literally just want a raw value 1. So that we basically have a black and white image. So render an image of this. I've already done that part, as you can see, if I can even find it. You can see I've already done that. I've created this texture, but once you have this, we are ready to get started. Okay, fresh Blender scene, let's make it. So, cube, get rid of it, replace it with a plane, just like last time. But this time we're actually doing the full booster pad. So, into shading workspace, let's make a material. I'm going to call it booster material. If I sound myself a bit boosted, it's because I'm still a little salty over needing to do this recording again. It really was pretty good, but hopefully this will give me a chance to explain it even better. So, we have a material for this, and before we begin, I want this plane to be a bit wider, kind of the shape of the booster pad. So I'm not just going to scale it on the x-axis like randomly, I'm going to scale it by 5. And you could do it by 6, 7, whatever. Point is, whatever number you scale it by, remember it, because we're actually going to incorporate it in the material. As for the material, I don't want any of this BSDF stuff. We need to make each part of this design, the colors, the arrows, etc. And because we already made the arrow, let's start with that. It's super simple. We're going to use an image texture and import in our image of an arrow, again, that you made. Or you could find one online, but it was so easy to make that I just would. And you can see what happens is this image texture is pasted on this plane, but it's stretched. Because in edit mode, remember, we did this thing, so it stretches the image. Now, this seems like it's bad for us, but this is actually incredibly good for us because it's going to make a lot of shortcuts. If we now take this image texture and go into the coordinates, and we're going to be using UV coordinates for everything, okay? We go into the UV coordinates, we can now, just using a bit of vector math, I'm going to take this and I'm going to multiply it. In other words, I'm going to stretch the coordinates, not by 1, 1, which does nothing. But on the x-axis, we increase this to what number? To 5, because that's how much I, in edit mode, stretched it. If you did it to 10, you make it 10, whatever. But you can see this takes our arrow and repeats it. Why? Because this image texture is already set to repeat. If it was set to clip, you can see the stretching does, it does stretching, but it only has a single image. Because this is set to repeat, we get this for free. Even better, we take this and now we do an addition. So multiplication, stretching, addition is adding, it's translating, right? We're going to add a vector such that the y has some component that isn't 0. And you can see now we actually have this pulsing arrow thing. So we get the tiling and the translation, which again is a result of this repeating. That's why this works completely for free. To animate this, right, because we want it moving over time, in the y component, I'm going to type in a driver. If you haven't seen this, this is going to be the frame number. It's going to give us time. I'm going to take it and divide it by, let's say, 60 or something. Just so it goes 60 times slower than like every frame is a second kind of thing, right? And in fact, we can put a negative sign in front of this, and that's going the other way. And you can see for free, basically, just from a quick image texture, we got the moving arrows. And now all we need to do is the checkerboard, the color, and like the dots, and that's pretty much it. And you're going to notice that this little stretching and translating thing is going to keep showing up again and again and again. So make sure you pay attention to that. Next, I'm thinking probably the next most important component is the color. So I'm going to create the color using a little trick. I'm going to use hue saturation. Why? Because hue saturation, it lets you pick a color. And then as we move the hue, you can see it's giving us different kinds of colors. If we do this on a gradient, then we're going to get all the colors for free. So how am I going to do this? I'm going to separate our UV coordinates. In fact, I'm going to use this version that's already scaled by 5 because, the plane's 5 times bigger. Everything we do, by the way, from this point on is going to use kind of this node onwards as kind of a base. But we're going to separate this so we can look at not its x component, but its y component, this top-down gradient. And we can now send this through this hue saturation node. And for free, I know, I keep sounding like a salesman, we now get this rainbow, because we take the color red, and as we go up, we are shifting the hue. And just like last time, we have this multiplication, we have this addition. This is a recurring theme, because if I take this y coordinate, and this is cyclic, because hue is cyclic in the same way that the image texture is set to repeat. If I now take this and add, you can see, whoa, we're getting animation easily. So I'm going to do the same kind of thing. I'm going to do hash frame, not 60 this time, but 40, so it goes a bit faster. And the reason I don't want them in sync is it's visually more interesting when they're out of sync. And let's also, so crammed in here, let's take this and set it to a negative number. And whoa, now we have colors moving. To overlap these, because now we have kind of two things going on, I'm just going to mix these components. How do I want to mix them? I just want to say, take the arrow as a factor and slap it on top with whatever custom color. So the factor is basically saying, reveal this color wherever this image is white, which lets us actually pick the color of this. Now, I think I went for white, but you could also kind of go for a golden yellowish kind of thing, whatever you want. But you can see this looks interesting. One thing that's very disgusting about this to me is there's kind of too much color going on. So in the same way we did the stretching from before to get the right kind of look for this, we do the same thing, but now in one dimension. We take it and we multiply. I think the closer it is to 0, kind of, yeah. So I'm going to, oh god, it's windy out here. I'm going to set it to 1/3, and that's going to stretch it by a factor of 3. If we divided it by 3, it'd be the same thing. We do that, and now this looks much more kind of contained. We can make it even nicer, 1 divided by 4. And now we're getting like 1 or 2 colors at a time, and it's not overwhelming. By the way, color management standard. Okay. So we kind of have 2 components very quickly. Again, this multiplication addition in vectors appeared again here in scalars. So this is a thing that just going to kind of keeps showing up. Next thing that we could do super simply, so I say we just do it now, is let's have a checkerboard, but not going up and down like these, but going left and right. The nice thing about checkers, we don't need a texture. It already has a node for us. It's called checker texture. You can see we have this checkerboard texture. We can make it smaller, bigger, but the aspect ratio is wrong. Again, we have a stretching by a factor of 5. So if we take this node, or actually we branched it off here, connect it, everything's fixed. So again, everything from this point on is going to be using this kind of branch point as the beginning. So we have this checkerboard texture. How do I want to incorporate it in? Well, I'm going to mix it with our color. It really sounds like there's a storm coming, huh? Okay, we're going to mix it with our color. How do I want to do it? There's a couple options. I'm going to multiply it so that wherever the texture is kind of, checkerboard is kind of closer to black, it's going to take away from our color and make it less luminous. Because I think that looks good. And just like everything else, I know I keep saying it, ramming it into your head because it's important. We can use the addition idea as animation. In this case, we want the x-axis because it's going left and right. So hash frame divided by 60. And boom, we have color, we have checkerboard, we have arrows. So this is kind of like the entire look of it. And now we just need to stylize it in a way so it doesn't look like garbage, right? But you can see all the components are there. So how do we make it look more stylistically good? Well, that's kind of up to you. What I found is there's kind of too much going on. It's very busy. There's these gradients where the colors are nice, but you kind of see too much, and everything's kind of sharp and like, ugh. Kind of like 60 frames per second animation is what it reminds me of, right? Even though it's actually 24 FPS. So one thing we can do is we can pixelate it, kind of make it lower res, which ironically makes it look kind of better, even though we're removing detail. And after we pixelate it, I don't want just this kind of rectangle, kind of like this flat slab that we can like duplicate and make, you know. I want it to only appear in some areas using dots. So let's do both those things. With the pixelation, this is kind of conceptually hard, but very easy to implement. Remember, everything we've done, all these nodes, which by the way, it's time to save, because I don't want to lose another recording. You can see here, never too late to save. That's the actual blend file from the missing tutorial. So whatever, we're never recovering that. It's never too late to call OBS tech support and like yell to them, more like. But because all of these nodes are dependent on this, not just the UV coordinates, but these modified by 5 UV coordinates, if we manipulate something here, it's going to propagate down the chain. How do we want to manipulate it so that it pixelates? Here's the trick for how to do that. So it's going to be a bit weird. I'm going to use a vector math node we want to somehow, so you can see this is manipulating everything else, we want to somehow take our coordinates, keep them the same, but instead of having them be continuous, I want them to be discrete with a lot of rounding, right? It turns out snapping is kind of the fastest way to do this. And I'm just going to drop a couple nodes, and then I'm going to explain what I'm doing. So I'm going to take math, I'm going to divide 1 over a factor that I want to be able to control. Okay, so let's see what we have here. So you can see what this does, and I'll explain it in a second, is it takes what we had before. It's exactly the same. You still have the checkerboard, the arrows, whatever. They're moving at the same speed, but it pixelates it. How much does it pixelate it by? This number. So the lower it is, kind of the lower res it is. So you can kind of get ridiculous here. And as you go higher and higher and higher, it almost gets continuous. In my experimentation, I like the look of 16. So now the question is, why does this work? What snapping does is, you can see we have this, well, first we have UV coordinates, which are subject to stretching. We multiplied it by 5 to accommodate for this, but it's still this continuous thing. Don't worry if you don't know what this means, but you can see it's still kind of a gradient. What snapping does is it takes it and makes it discrete. It's going to say, look at the x and y axis and snap and round and go to the nearest 1 over 16. What this means is that vertically you're going to see that there's 16 little tiles, and horizontally there's 16 times 5, because, you know, we stretched it by 5. If we make it a smaller number, it'll be more obvious. We've separated it into 3 tiles vertically and 3 times 5 horizontally, and we can just keep increasing that. And because this is now discrete, it forces everything down the chain to be discrete. Okay, we can kind of take this idea, so it's already looking a bit better, ironically. We can take this idea and push it even further. What if for every pixel, which we can control the size of, it's not just whatever color it is, but we say only show kind of a circular mask of it. So this is kind of the final component. Well, to do that, we're going to be using a similar idea. We want the same pixelation by 16 or whatever number, but instead of snapping, I want to kind of repeat, which is different than snapping. It's not pixelate, it's just saying repeat a circle. Again, I'll explain this in a second. So we're going to take this, again, everything we do is dependent on this UV coordinates multiplied by 5. We're going to take it, and this time we are going to first scale, and then we are going to take a fraction. And I'll explain that in a second. First, we need to find it. Fraction, what do we scale it by? 16. You're going to see what this does is it does something a bit different. Whereas snapping took our coordinate system and made it discrete, what fraction does is with the same pixel size. You can see these squares are the same size, but they're different squares. What fraction does is for each square, same size, it's going to kind of fit or jam a whole UV coordinate system inside of there. This is useful because it's repeating, but it's still continuous, so we can generate a circle in all this. Again, you want to make sure that this is the same number, otherwise the pixel size won't be the same. So 16. How do we use this to make circles? Like, we have a bunch of UV coordinate tiles. That kind of seems useless. It's useful because if we had a single UV tile, like a 1x1 square, think about how you'd make a circle. We want to say, kind of calculate the distance from the middle, 0.5, 0.5, and radially increase that as a radial gradient. We do that, but now it's just going to repeat for each pixel. What do I mean? Take the distance. So for each one of these tiles, I want you to output, Blender, the distance from every point to the nearest 0.5, 0.5, which you can see kind of generates this radial gradient. So again, we have these. For each tile, I'm looking halfway, 0.5, 0.5, so right here, and right here, and right here, and I'm saying give me the distance. So where it's very close to that, it's going to be black, 0, and then it radially grows. The idea here, though, is if we now filter this through like a greater than or a less than, I guess it's going to be less than, we're taking the radius and kind of clamping it. So don't worry about it too much. But this is the nice way to generate a grid of circles so that, and here I guess we could skip a couple steps. Like we could just use a transparent BSDF, but I'm thinking let's go for the whole tamale, okay? We're going to throw this through a principled BSDF. It's going to have the color of that thing we just made, and it's animated. But the alpha where it's going to show up is going to be dependent on the circle map. So let's calculate, or rather input the alpha. And you can see what it's going to do is it almost does it, right? And now you can see each pixel is a circle, and each circle has a color. And notice if we didn't make it discrete, you're going to notice that each pixel can take on multiple colors, which is why it would look weird this way, right? But the pixelation is what makes it look good. We're going to take the alpha. However, instead of being transparent, you can see that there's black there. Oh my god, I need water so bad. I wish I knew where the water was. So what I'm saying here is that we have the right idea, but our material doesn't have any transparency. Why is that? It should, right? Because we did the alpha. It's basically an artifact of Eevee. You have to go into the material, and in the material, set this to alpha blend, the blend mode. This is what's going to let us actually see through it. So if I had an object, like a torus, underneath it, you can kind of see it poking out from the circles. It actually has transparency. So there we go. I mean, that's kind of the whole idea. To make it look kind of more like ephemeral or more like video gamey. I don't know why I said ephemeral. We're going to plug in the emission so it actually glows. And because we're in Eevee, let's just enable bloom. So that when we bump up the emission, it kind of has the same thing, but now it glows. That's probably too much. But that looks pretty good. So you could see, without that many nodes, we made this almost entirely procedural minus the arrow texture, right? But basically, entirely procedural thing. By the way, if you were to scale this up, let's say we stretch it on the y-axis by 2, you could see it almost does the right thing, but not quite. That's because we need to set this to 2 and wait for that to load. And now you could see, sorry, I'm losing my voice here. You could see now everything is working fine. One more thing before we move on to the next part. I just want to really emphasize before I lose my voice. Everything here is dependent on UV coordinates. Why did I do that? For fun? Well, kind of. But it actually has a major advantage. Because it's dependent on UV coordinates, if I add like a loop cut or something, and then I move it, you could see it stretches with it. Why? And that kind of seems like a weird point. It's useful because if I had a lot of loop cuts, and I apply something like a simple deform, lordy, and I set it to bend, oh, this is what death looks like, guys. You could see the point though. We could take this image texture, and we could take this thing we made and kind of use it for a lot of different shapes, like circles. Okay, this is the end of part 1. Now let's let's talk about motion tracking and how to put it in our shot.
Okay, part 2 of the tutorial. We need to motion track some footage. I just found this mansion. It's actually like a 2-part mansion, and I thought, why not record it out here in the wind? But yeah, part 2. What we need to do is we need footage that I've already collected. Let me show you if I move my OBS scene. You can see you could do this with any shot. But here's the one I chose. We need to track it so that when we know how the camera's moving, we can put 3D objects into scene, namely the booster pad that I made last night, where I swear to God, I had like pneumonia or something, but that's what we got to do. So how do we motion track? Super simple. By the way, I've already done like in-depth tutorials on tracking, so if you want to see something more in-depth, it exists. But here's how we do it. Go to the movie clip editor in a fresh Blender workspace. This is where we do our motion tracking, and by the way, this is going to be a common theme here. I can barely see the screen, so I'm squinting hard. I load in the shot, so it's actually loaded into the movie clip editor. And before we do any of our tracking, we just got to make sure everything's set up so that I like it. First of all, in the render tab, if I can even see that, go to color management and set the set the view transform to standard. You can see what this does is it makes our shot not look weird because we had this filmic kind of cast on it. Standard makes it look like the way that we filmed it. And second of all, go to the output settings. You can see here I shot this at 29.97 frames per second, but our project's at 24. By the way, sorry if there's wind. What can you do? Match the frame rate. Once you've done both these things, neither of them matter for tracking. I'll just be happier. Now that we're ready to start tracking, hit set scene frames. This is going to make sure our project out point is at 150 frames because that's how long the shot is. So before it was 250, it shortens it, and also hit prefetch.
So the whole shot is loaded into memory. And you can see now we have a correctly colored, correct frame rate shot playing. And all we need to do is motion track it. Now, normally what we do is we add a tracker. I say, oh, this is what makes a tracker good, bad, and you do that whole thing. I'm not going to do that. I'm just going to mass add trackers. First of all, I want to make sure those trackers that we're going to add have the correct settings. So normalize, make sure that's enabled. This is going to make sure that every tracker that we're adding doesn't care if the lighting's changing or if there's a shadow. It's normalized to it. It's a good thing. And for the match, I'm going to set it to previous frame so that instead of tracking one pattern across the shot, it's going to always look at the previous frame and compare one frame to the next, which basically makes it a bit less accurate, but it makes it a bit more sticky. The tracker is more likely to stay on target. Other than that, I think that's good to go. So let's detect features. And you can see we have a bunch of trackers. And the important thing to notice here is every tracker is going to inherit these settings. Cool. Go to track forwards, or hit Control T. And you can see all these trackers are tracking forwards. Beautiful. Let's add more trackers. I'm going to detect features on the last frame. We can also track backwards. So with these new trackers, either hit track backwards or shift Control T. There was an Ian Hubert tutorial that was like this. It was like, if you don't want to learn how to motion track, just the detect features thing. But it really does work. So here you can see now we have a bunch of trackers. And what we'd like to do with these is use them to get a camera solve. But you know, don't get ahead of yourself there, because if I look at this tracker data, you could see, you know, it all generally looks the same, but there's some trackers that are very kind of off. Like this one, you don't even need to know what this means to know that it's off, right? What it does mean is the XY data isn't representative of the rest of these. We need to somehow kind of detect these trackers, and I'm just clicking and deleting them, and we want to get rid of the worst trackers. You could either do it literally the way I just did, or I believe there is a automated way to do this. Go to Solve, make sure all your trackers are selected. Maybe this will block the wind just a little. And what you want to do is in Cleanup, we want to filter trackers. So we want to filter the ones that are the worst. And I've used a threshold of 7 or something, which hopefully selects some of these, and hit delete. I think that got rid of 1 or 2 trackers. This will get rid of the trackers that are least similar to the others. So hopefully at this point we have good enough trackers. I'm just going to add 1 or 2 more manually because you can see all my trackers are on the ground, which is a good thing, but you want some that are like higher up. So I'm just going to add a tracker, Control click. So this is how you actually add a tracker, Control click, scale it up, Control T to track it forwards, and I'm going to lock that in. By the way, if I didn't tell you how to lock trackers before, once you're done tracking it, just hit Control L. So I just added 2 trackers. Maybe we could do 3 on the cart so that we actually have data that is not at all at the same elevation, and hopefully that's enough. So at this point, we're going to go to Solve and pray that everything worked. Before we do our solve, there's a couple settings we need to pick. 1, keyframe. Do we want Blender to pick it for us, or do we want to pick 2 numbers? I find that picking 2 numbers is usually good. These 2 numbers are representing frame numbers, frame 1, frame 30. And I want to pick these so that between these 2 frames, we have a lot of trackers in common, but the camera is moved a lot. There's a lot of parallax. So let's see, frame 1 to frame 30 is not bad, I mean, honestly. So I'm just going to keep it. Let's try to solve camera motion, see what it gives us. Okay, so it gave us a solve error of 1.25 pixels. If you have no idea what this means, neither do I. Well, I do. This is the average drift of each tracker compared to its 3D position it just calculated. What it means is you want this number to be low. If you can get this under a pixel, you gooch. 1.25 isn't horrible, but let's try to optimize it a bit. So, given the solve that's 1.25 pixels, can we do a bit better? Yeah. I'm going to keep these keyframes. Looks like the pneumonia's back. The only thing I need to change is I'm going to enable focal length, so it's going to keep the same keyframes, all this, but now it's going to try to figure out how zoomed in my camera was, because if it doesn't have that accurate, that could be cause for concern. So let's solve camera motion, and now we're well under a pixel. So, perfect. What it did technically is if you go to track, you go to camera, you go to lens, you could see now it's calculated my focal length to be like 27 millimeters, which I don't think is right on an iPhone, but whatever, I trust it. Okay, so we're done tracking. Now we just need to put this in our 3D scene and make it compatible so we can add things. Here's how you do it, super simple. I'm gonna add a 3D viewport so you can see nothing's happened in the 3D viewport. It's just a cube and nothing. We want to import in all this information we just calculated. So, by the way, good time to save, because my laptop's been, I mean, I slept last night in like 20-something degrees, so I understand, but the hard drive's been fucking up. So I'm going to call this tracking Please don't corrupt the file. Here's what we need to do. Hit setup tracking scene. You could see it's added a plane, a camera, and a couple other things. But the important thing, when we go to our camera view, you can see, oh, we have a track. It doesn't look perfect, but you can see all this information. The camera itself has been pulled into here. You can see if we look at our camera, it is now moving through our shot. I can't see it because of the sun, but I'm sure you can see it. The reason it's looking a bit off is all these trackers that we've calculated, which we can actually see if we enable motion tracking as a bunch of empties, they're not they're not on the ground, they're kind of hovering. And the plane is supposed to be on the ground, so of course these things don't really connect. To fix this, I'm just going to pick 3 trackers or 3 empties in 3D space, whatever you want, that are on the ground, and I'm going to say these 3 trackers are the floor. And you can see now everything looks a bit better, but it's huge. So I'm going to make it a bit tinier. I'm going to select 2 trackers, hit set scale, and if you want to set the scale to something different, pick a different number and set scale again. Basically what this is doing is I'm saying these 2 points, if you look at their 3D position, how much distance should there be in between them? I'm saying 1 unit, and I'm setting scale. Either way, you can now see all these empties are fairly close to the ground, which means it's oriented correctly. And if we move our camera through the shot, as you can see, everything looks good. So actually, I can close the movie clip editor now. We don't need it. The key takeaway is anything we do now, I'm going to get rid of the motion tracking stuff now. Anything we do now should look like it's sticking onto our shot. So the plane's there. If I wanted to add a torus kind of hovering above, whatever we do will look like it's sticking on. So of course, the name of the game is taking the booster pad we made before, appending it into this one file, and doing that whole thing. But before we do that, and that's going to be part 3, just a couple administrative things so we don't get confused. And for this part, I'm actually going to move my camera in OBS. I know this is the most janky recording ever. The reason I'm moving my camera is there's a couple things we need to take care of, and a lot of them are on this top right corner in the outliner. So when we hit setup tracking scene, it didn't just give us the glorious camera where it needs to be. It fucked up our blend in a couple ways. So you can see we have a foreground collection, a background collection, multiple render layers. I don't want any of this, okay? So I'm going to delete all of these collections so that all the objects are in this scene. I don't want them separate. And more importantly, take the background view layer and delete it, okay? The reason it added all this is normally when you're doing the camera thing, you want your shadow catchers and all this on a separate view layer so you can control it. I don't give a fuck. And really, it's just confusing everything. So I want everything to be in this one foreground render layer in one collection. And in the compositing workspace, you can see, whoa, it's added all these nodes. Normally, there's just one node. Again, it did this in theory to help us, and it kind of did help us, but you can see it imported the footage, it undistorted it, scaled it, a whole bunch of stuff. I don't need it. So I'm going to get rid of these nodes, this node, and this is all we need. So that we have our footage. This is the movie clip from the movie clip editor, right? You can see as we play this, it's playing the shot. And I want that underneath the render layer. So whatever we render, in 3D space. So again, let me just add in that, monkey. I want this to render on top. Now the issue is, by the way, if we go to the render thing, you can see the background's not poking through. So go to film, go to transparent, and now let's try to render. I'm going to render 1 frame in Eevee, and beautiful. You can see it looks horrible, but it's in the shot because we have this render layer, which is what we rendered. We have the movie clip editor synced up to the same frame, so that when we do this, one is on top of the other, and it looks horrible, but it is correct, as you can see. So we've done. Let me get my OBS. Hopefully the wind isn't too bad. If it is, I'll move to a different location for this last part. But what was the point? We've done the motion tracking. We basically have our blend file set up now to basically paste the booster pad on top. So in part 3, which I will record later today, let's do that. Yeah. Oh, and by the way, sick mansion, boy. Have you tried living in a tent? Okay, the third part of the tutorial, I found this location by the water, but more importantly, I found this pile of sticks, which I think is representative and indicative of how this tutorial is going. It's getting more and more chaotic, but nobody set it on fire yet, because we're still getting the information out there. So, in part 3, what have we done so far? We made the booster pad, we've motion tracked, my phone's going off, we may as well set the fucking sticks on fire. And the last step is, now that we have all of that, we want to put the booster pad in the motion track shot. So I guess let's do that. And by the way, I can't really see the screen again, and I
assume that you probably can't see me either because the sun's back here. But let's do it. Whatever. Let's just finish off this shit show. So we have this motion track thing. This should be the same as the end of part 2. All we need to do is put in the booster pad. So I'm going to delete this, and remember, any object that we add into our scene will be tracked appropriately. So let's append from the previous blend file the booster pad. So type F3 or spacebar, whatever your search command is, append, so you can import in something from a different blend file. And I think the one we did was never too late to save, or the please don't corrupt. Either way, I've done this a couple times. Just take the booster pad you made. I think the best one I made was this one. Go to Object and import in your plane, or if you gave it a name, your booster pad. So the only difference between this one and the one that we made together is you can see it's exactly the same thing, right? Except I faded off the edges a bit just to make it look better. You could just do that with a gradient. And I think I also did a Fresnel effect, where if you look from above it, it kind of gets more transparent, because I thought that looks cool. But generally, it's the exact same thing. So because we're in Eevee, all we have to do is kind of put it down. No need for shadow catchers or anything like this. So you can see the direction's kind of going that way. We could either fix this by rotating our object or doing the UV thing. I'm thinking let's just rotate our object by, that didn't seem to do anything, by 180 degrees. Yeah. And let's position it so that it's kind of contained within the line. And because it has this nice fade, should kind of blend in a little. So something like that. And let's rotate it a little. And I'm happy with the way that looks. Because this is just a thing, just an object, we can take it, Shift D to duplicate along the Y-axis, I guess. I'm going to put another booster pad down here. And just to show the variety we can get from this material that we made, what I'm going to do is I'm going to scale this up by 2 on the Y-axis. You know what? No. I'm going to scale it up by 4, living dangerously. So we have a longer one, and remember, we need to correct for this in the UV coordinates because they stretch. So for this one, you can see they kind of share the same material. So I'm just going to unlink this so this can be booster long. So that when we look at this material and this material, they're separate. And for this one, I'm just going to, wow, this one's a fucking mess. I'm just going to stretch it if I can figure out what I've done here. Yeah, there we go. So I've stretched it by a factor of 4. So maybe this should be set to 8 now. I would recommend maybe using the previous booster, but you can see it's accounted for this. This part doesn't matter. I just want it to kind of look cooler. So I added in a second one. I'm going to rotate it. Doesn't need to line up perfectly, but the better, the better. And there we go. We got our booster pads in the shot, okay? Now, hopefully in the compositing, yes, I already got rid of all these nodes. Well, we did that together. So now all we need to do is kind of make this look good. If we were to hit render right now, we get this, and it's overlaid on top. It looks fine, but we could do better. First thing, we're in Eevee. Let's use some of that bloom. So enable bloom, and what bloom does is it kind of gives us this blurry kind of glare effect, which becomes more and more powerful depending on how strong our emission is. What have I done with this material? This is insane. Either way, you probably have a principle to BSDF. Just take the strength of the thing and increase it. What have I done? Oh my god. I'm going to bump up the emission here, and I'm going to bump up the emission here. And in the bloom settings, we could even customize it even more, change the threshold and all that. You can see this is adding just a tiny bit of glare, make that more intense. I like the look of that. Another thing we can do for free is in Eevee, just enable motion blur. Calculate 6 steps of it so it looks a bit better. 0.5 is fine. These are just things we're adding to kind of give a better overall effect. Yeah, I like the look of that. Oh my god, so much wind. Let's render a frame. And now you can see it's looking a bit kind of more glowy and all this. I'm thinking final thing we can do in the compositing is if we bring down the factor, this should make it kind of more transparent. And I don't want to bring it down a lot, but just enough so you can kind of see the ground through it a little bit more. So here's the before and the after, just to kind of make it blend in a bit more. So I think that's pretty good. And maybe a final correction is we could do a tiny bit of color correction as our correction. So I'm going to do hue saturation for the render layers. So you can see if I bump up the saturation, it's going to make these colors like nuclear. Just play with it until it looks like it kind of fits the scene. I think a bit of a desaturated look actually fits this quite well because it kind of looks very overcast and all this. And maybe let's also add in a gamma node just to play with the gamma. So you can see if you bring it one way, it does one thing. If you bring it the other way, it's going to get blown out. So let's just increase it by just some. And I like the look of that. So let's try out one more frame. So let's see one here. Render it. And yeah. It looks great. It looks great. Long story short, you just want to basically do whatever you want with this in terms of positioning, because again, this relies on UV coordinates. Feel free to like add in a loop cut wherever you see fit, and you could delete part of this and have it be half a booster pad. The choice is yours, like really. But I just wanted to show you how you could render it. So instead of rendering a frame, now you render the whole video. So I think that's the end of it. What a fucking shit show of a tutorial, but I liked it. Hopefully you learned something about making the procedural booster pads, or about motion tracking, or just how to incorporate everything together with Eevee. I know everything was scattered, there was wind, I'm going to figure all this out, but this is my first time kind of doing a tutorial like out and about and all this. But either way, if you learned something, great. I hate it when I say either way. I catch myself doing it 100 times. It's like my go-to phrase when I'm wrapping something up. That being said, either way, this video and all my tutorials are brought to you by the very, very glorious patrons. There's a link in oh no, the coughing's back. There's a link. There's a link in the description if you want to join the Patreon. You're not only going to get to support both this channel and the CG Matter channel, which is great. It's the only reason I can make tutorials on the road and have it be like a thing, but you get stuff in return. So for this project, you can get the blend files in terms of the booster pad, the finished one, and also the original shot that you can use for tracking. Get the project files. You don't need to make this yourself, or you could play around with the finished project. Get the blend file or... the blend file for any other thing I've made over the last 3 years. There's hundreds at this point. Also, early access for tutorials. This one maybe no, because it's a sponsored one and I have scheduling issues, but in general, you get to see tutorials a bit early, and exclusive tutorials that are only available to patrons. That's another thing you can get this month. I already did a exclusive tutorial. That's, you know how you can distribute points on faces? There's a geometry notes thing for this. I wanted to distribute it inside the volume using a fancy technique. I saw Arendelle did it, and I came up with my own method that may or may not be the same as his, because I didn't look at his node group. But if you're interested in any of that, check it out. Or if you want to support these tutorials, that's the best way to do it. Either way, thanks for watching the shit show. Next time, I'm going to find a less windy spot with less glare and all this, and I'm going to do it in one take instead of splitting it up into 3 sections. And that's it.